Hi, welcome to interview practice. Problem 2, balanced parentheses. We're gonna take a look at the problem, think a bit, and then kind of jump into the editor and interactively develop a solution. In a real interview, we'd probably use the whiteboards or more, but that's kind of hard to record, so I'm just kind of going to do it more in the editor. So the problem is we have a string of parentheses and we are asked for the longest substring of balanced parentheses. So strings, we know, right? We're just going to assume that this string actually doesn't contain anything except parentheses, which means we don't have to handle a case where there might be any like other letter in here. And then there's a question of what are balanced parentheses. So we have the open parentheses and close parentheses, right? So the screen pair here, these are balanced. This is a balanced pair, and then the surrounding pair is also balanced. And the orange example here is a string of balanced parentheses, right, which continues because there's nothing else in here. And this is obviously 4 characters longer than this one, so the correct answer here would be 4. We have a function, we're just going to call it longest balance, which is going to return a result. It's going to take a string, and that's for now. And then we're going to do some test-driven development by just calling this in our main method and seeing what happens, so we can iterate on it. And let's start out with something simple. So what we want to do is iterate over our string and find the matching parentheses. How do we do that? We can kind of start out, right? Just iterating over a string, we know how to do that. For character in string, print character. We're also going to print our input string just so that we know what's going on in our output. And now let's just run this. Yeah, so we see we're iterating, open, close. So now we can try to figure out how we're actually going to find the matching parentheses, right? So we know that we have open parentheses, close parentheses, these match, right? Another open, close, these match. So then we can also have the case where we have like 3 open parentheses, 1 close parentheses, 1 open, 1 close, 2 close, right? And we can see the outer ones match each other. So we can't just like match each parenthesis with the previous one that occurred, right? Because like these two, like they're now matched, and this one is skipping over 2 others, right? So to me, this kind of sounds like a stack, right? So we can just try slap a stack on it. I'm just going to use a list and just append to this list. So Python lists can be used as stacks using append and pop, right? So we can say if char is open parentheses, if char is close parentheses. So on the open parentheses, we can just put this onto the stack, right? And on the close parentheses, we can stack pop the matching parentheses and just kind of print. Right. So let's try that. Yeah, so we have the open that was on the stack. Close, we popped it off, and we found the matching open parentheses. So that's not super useful because all pop is ever going to return is going to be the open parenthesis character, right? But we actually want to figure out the length of this matching string. So what we really want is the index of the open parentheses. So we can say I and enumerate. And instead of the character itself, because we know it's always going to be an open parenthesis character, we put the index on it. So if we try this now, that should return 0, right? Because we know that's matching index 0. And if we change our input string to have 2 pairs just adjacent to each other, it should still work, right? So this parenthesis here matches 0. This one matches this one, which is the second one. Great. So what do we do now? We have the index of the open parentheses. Let's do that. Open index is that. And now we can try to compute the length of this matching string, right? Length, just, our current index minus open index. Print that. And it tells us 1, right? Because we were just comparing the indexes, but they're actually both inclusive. So just fix that by adding +1 to it. So now it should return as 2 for both. Great. So now we know the length of matching parentheses. What happens if it's a more complicated input? So if it's like this, right? The outer one match and the inner ones match. What happens in this case? So now we can see we're pushing the first open on the stack, pushing the second open on the stack. Then we're popping this one from the stack, right? That's this one, and we get a matching pair of length 2. And then we're popping this other one here off, gets a matching pair of length 4. Nice. So, and now we're asked for the longest pair, so we just kind of keep track of the longest length that we found so far. So it's 0, and say if length longest yes, length. And at the end we can return this. Nice. So, and now we can make this a nice test and assert this should be 4. Let's see what happens. Yeah, our program finishes. Okay. So let's try some other test cases. What happens if we have matching parentheses and another open parentheses? Right, this should be 2 because the first one's match, and the second one just gets ignored. Let's see what happens. That's fine, right? So this one gets popped on the stack, pushed on the stack, I mean, popped off, length 2. Next one gets pushed on, and it just stays there, and then we've reached the end. Okay. What if there is another closing parenthesis, right? So you can try to predict what's going to happen, right? So we're going to push this one, pop it again, and then we're going to encounter the last closing parenthesis here, and we're going to try to pop it. What happens in that case in Python? Oh, it's going to return an index error. we don't want that because this is actually like a valid string and it should return a valid result. So what we want here is to also check that the stack is not empty. So we can say if stack int derivatives, and now this we're only going to try to pop if the stack is not empty. Nice, great. What other examples do we have? We can have something like this, right? Where these match, they're adjacent to each other, and then they're surrounded by another matching pair. So this should be size 6. And then of course we can also try the given examples of which was supposed to return 4, and the longer one which was and all of these return correct results as expected. Yeah, so you can just clean this up. We need our debug statements, and that's it. All of our tests pass, and that's an acceptable, nice solution. Maybe sometimes in an on-site interview we're also going to be asked about complexities, right? So we could try to figure out what the actual time complexity of this solution is, right? So to do this, we can kind of walk through it and just add up the complexities, right? So creating a stack is free, and then we enumerate over the string. Appending to the end of the stack is O1, right? So we can add a comment O1. And the popping from the stack is also O1, right? Because it's just shifting the pointer further. And then this if, yeah, also O1. And we're going to do this whole thing in one iteration over the whole string. So this entire loop is going to be O(n) time. So which makes this entire function O(n) time. And what about the space, right? We have the stack here, so we're using extra memory. What could be the maximum length of the stack, right? So if that would be if we only append and we never pop off, right? This can only happen if the string just only contains open parentheses, and it might at most contain n open parentheses. So that's O(n) space, which is good enough.